Hello, fifth graders. So today we're going to work on pages 8 through 11 in your math instruction book. Remember that you can either use this video to work the problems or you can watch it afterwards to check your answers. I'm going to try today to work in the book so we can see the colors, and hopefully that will be helpful. On page 8, it's basically just wanting you to start thinking about how the numbers work. So it says numbers like 10, 100, 1000 that can be written as products of tens are sometimes called powers of 10. Multiplying and dividing by powers of 10 is related to place value, and we're going to look at the numbers 30, 300, and 3000 in the place value chart. Something I want to add here that isn't here, we have 3 equals 3 times 1. I just want to have that in there so that we can make sure that we understand that 10 is a multiple. 10 times 1 is a multiple of 10. And I want you to notice the pattern. So 30 equals 3 times 10. 300 equals 3 times 100. 3000 equals 3 times 1000. So that is a pretty simple concept that we probably have learned in the past. Here is the same thing written a different way. 30 equals 3 times 10, 300 equals 100, or 10 times 10. And we're going to start seeing this, that this also means that 300 equals 3 times 10 to the second power because it's written 2 times. 3000 equals 3 times 1000, or 3 times 10 times 10 times 10, or we might say 3 times 10 to the third power because it's written, or it's 10 3 times. 10 3 times. So you can see a pattern when you compare the number of zeros in the factors to the number of zeros in the product. For example, there's 3 zeros in this factor, so there's 3 zeros in the product. The pattern can help you multiply and divide with powers of 10. This page, number 9, is also just explaining some things, and then we'll start answering some questions. Think of dividing by 10, how it undoes multiplying by 10. And here we go. Let's see. I apologize if me trying to get my screen figured out is frustrating. So if you multiply a number by 10 and then divide the result by 10, you end up with the number you started with. For example, 3 times 10 equals 30, and then 30 divided by 10 equals 3. So this happens because multiplication and division are inverse operations. I'm sure you've heard that phrase before. Dividing by 100 is the inverse of multiplying by 100. Since 3 times 100 equals 300, you know that 300 divided by 100 is the same as 3 times 100 divided by 100, or 3. It's a lot of words to have a very simple concept. This is just showing you the pattern. 3,000 divided by 10, divided by 100, divided by 1,000. And then it shows you again the patterns. The pattern you find in dividing by powers of 10 are similar to the patterns in multiplying by powers of 10. So notice you have 3 zeros divided by a 1 0, and you get 2 zeros back. So you can use the pattern when you divide by powers of 10, and notice how the number of zeros in the dividend and the divisor are related to the number of zeros in the quotient. So we're going to do a little diagram real quick so that we can have a reminder of what a dividend is, what a divisor is, and what a quotient is. For example, I'm going to write out a division problem 2 different ways, and I'm going to do very simple ones. So I'm going to do 6 divided by 3 equals 2. It's the same as saying 6 divided by 3 equals 2. And I'm going to label with a different color, which is the dividend, the divisor, and the quotient. So the answer to a division problem is a quotient. Okay. And I'm just going to go ahead and say it is the answer to a division problem. And I'm going to try to get a little creative with my colors just so we can see a difference here. A divisor, let's go with the dividend first. So a dividend is the number being divided. So it is the number being divided. So if the quotient is the answer to a division problem and a dividend is the number being divided, what is the divisor? How do I explain and put into words what a divisor is? The divisor is what is doing the dividing, or how many groups it's being divided in. So I'm going to write divisor, just like I did the other items. I have quotient. So it is the number doing the dividing. We can word that a different way. We can say it is how many groups things will be broken up into. So that's important to know when we're trying to answer this question, or we're looking at our different numbers, how the zeros are related in the quotient and the divisor and the dividend. So for our reflect question, it says how many zeros are in the product of 4 times 100, 4 times 1,000, 4 times 10,000, and then the question, how do you know? So I like to just be very systematic, and I'm going to start with the first thing. If I have 4 times 100, I could write it out, 100 times 4, and I could go back to remembering how to do that. And so how many zeros are in the product of 4 times 100? There are 2 zeros in the product. Okay, and since I tried to do a complete sentence here, I'm going to make sure that I begin with a capital letter. So then my next question is, what about 4 times 1,000? I can do the same thing, or I can think in my brain and do some mental math. Well, I have 4 sets of 1,000, so I know that I have 4,000. And how many zeros are there in the product? There are 3 zeros in the product. And hopefully now you can start to see the pattern. So now I have 4 times 10,000. I'm going to do some mental math, and I'm going to think I have 4 sets of 10,000. So I'm going to have 40,000. And how many zeros do you see? There are 4 zeros. And I don't know why. I put a little line in my Z's so I can distinguish my Z's and my 2's. There are 4 zeros in the product. All right, we're going to move on to page 10. So we're now going to explore the idea, and we're going to explore patterns when multiplying or dividing by a power of 10. Thank you for being patient as I figure out the duck camera. So we're going to compare numbers of 5 and 5/10. How many times is 5/10 of 5? And we're going to use place value to explain how you know. How many times, so basically, how many times, remember, we're going to, when in doubt, draw it out, or when in doubt, write it out. How many times 5/10 equals 5? We can go back to the chart we had last week on page 3, and that can help us, or maybe we are starting to remember moving the decimal. So if I start out in my 10th place, oh, we can't see Mrs. Job, I apologize. If we start out in the 10th place, what do I do to get to a whole number? I'm going to multiply by 10. Always remember to use your resources. So I already have my equation set up. So I'm going to put 10 in the question mark place. 10 times 5/10 equals 5. So I answered that question. Use place value to explain how I know. Well, I might just say something as simple as, I know that 10 groups, we might go back to multiplication here. 10 groups of 5/10 equals 5. Or you might say, I know that when I use the power of 10 to multiply, I move the decimal place to the right, because that's what we did. Remember, there's an imaginary decimal place right after the number 5 here. Number 3, compare the numbers 5/10 and 5/100. How many times does 5/100, how many times is 5/100 is 5/10? I'm going to be honest, 5th grade, I'm not sure I'm a fan of how that question is asked. Use place value to explain how you know. So basically, they're wanting to know the same thing. How many times 5/100 equals 5/10? Okay, so you can go back to this chart we had on page 3, and I'm going to look at my 100th place, and then I need to get to my 10th place. So what did I do to get from 100th to 10th? I multiplied by 10. And remember, I said it'd be a good idea to have this chart in your notebook because we reference it often, and I already have so many colors on mine that it can start to get confusing. My next question says, use place value to explain how you know. So I might say, when I multiply by a power of 10, and really this is 10 to the first power because I only have the 10 one time. When I multiply by a power of 10, I move the decimal to the right. Okay, the number gets larger because I am multiplying. So remember, if I move this here, then it becomes 5/10, okay? Number 4, now use place value reasoning to fill in the blanks in the place value chart below. Look for useful patterns as you work. So really they're wanting to have you write the answer of this. So most of the time we always have the equal sign on the right of an equation, but here they're putting it on the left of the equation. So we're not going to let that confuse us. If I have 5 thousandths and I'm timesing it by a power of 10, which in this case is 10 to the first power, I just showed you up here how we're moving the decimal to the right. So if I move the decimal to the right here, then I'm going to get 0.05. So 5 thousandths times 10 to the first power equals 5 hundredths. Let's do the next one. Really, I'm doing 10 times 10, but we have learned and talked about earlier how that equals 100. I could say 10 to the second power. They all mean the same thing. So we're stretching our brain and we're learning how to think of math in different ways. Instead of moving the decimal just one time, I'm moving it 2 times. It's like I am multiplying it by 10 here, and then I'm moving it to the right and multiplying by 10. So my answer becomes 5 tenths. Are you starting to see a pattern? Are you starting to see a pattern that we moved the decimal right 2 times and it's a 10 to the second power? Next, we have 5 thousandths times 10 times 10 times 10, or 10 to the third power, or we could say we're multiplying it times 1,000. So our shortcut is we're going to move the decimal point how many times? I move it once for 1/10, one more time for 1 more 10, and one more time for 1 more 10, or I moved it over 1, 2, 3 times. So now I have a whole number of 5. So 5 thousandths times 10 to the third power, or 5 thousandths times 1,000 equals 5. Remember that division is the inverse, I'm going to circle that word inverse, of multiplication. So we're going to use that understanding of division of place value to fill in the blanks in the place value chart below, and we're going to look for some more useful patterns. This time, we're dividing. So we're going to do 7 divided by 10, or 7 divided by 10 to the first power, because it's only there one time. So if we move the decimal to the right to get a larger number, when we're multiplying, we're going to move the decimal to the left to get a smaller number when we divide. So for example, I'm going to rewrite the number 7 here, and we have an imaginary decimal right there. It's there, but we don't see it. So whenever I say I have $5, I don't necessarily always write a 5 and then the decimal. Okay, so I'm going to move this over 1 time because I'm dividing by a power of 10. And that means that now I'm going to have 7 tenths. Here I'm going to divide by 100, or 10 to the second power. And remember our pattern from up above, because it's 10 to the second power, or there's 2 zeros, I'm going to move this decimal over 2 places. So it started out here at right after the 7, and now I'm going to move it over 2 places. So I have to make sure to remember to put a 0 placeholder there. So now I'm going to have a 0 and a 7 there. Hopefully you're starting to see the pattern here as well. So now I have 7 divided by 1,000, or I might say divided by 10 to the third power. And that means I'm going to move the decimal to the left 3 times. 1, 2, and 1 more time, and make sure to have my 0 place value. Okay, here's our final page for today, page 11. It says, find out what happens when a decimal is multiplied or divided